Okay, let's keep going. And so we're still on exam 1 from 2015 fall semester, and we are on question number 5. Okay, so it says, what is the wavelength of an electron traveling at 4.38 times 10 to the 6 meters per second? So as you can see, this is a very typical de Broglie's wavelength problem. And if you remember from your formula sheet, there's a formula that says that the wavelength equals to, actually everything's wavelength equals to the Planck's constant divided by its this is momentum. And if you remember from physics, it equals to the mass of the object times the velocity of the object. And for some reason, Dr. Ma enjoys using mu as the sign that shows, oh lord, the velocity of the object. Let's make it, okay, so this is the mass, and this is the velocity. And that equals to, and this is a very straightforward question. It was proposed by Dr. Broglie, and who is a French scientist. And if you encountered Dr. Sauerlich in physics 1200, which is physics 2 over here, he will tell you stories about how he gets so jealous about Dr. de Broglie get a Nobel Prize only through his master or doctor thesis by proposing this formula, which is kind of fun. And it's kind of, and so the Planck's constant equals to 6.626 times 10 to the negative 34 joules per second, and the mass of one electron, which is also on your formula sheet, equals to 9.11. I get a little bit lazy over here by estimating some numbers. And that's the mass of the electron, and the velocity was a given data in the question. It's kind of actually so weird that since everybody is a wave, but some waves just don't really interferes with the others, but all waves should. Never mind. And so if you do the calculations in your calculator, it will get you 1.66 times 10 to the negative 10 meters, which is exactly 166 picometers, and that's answer B. And this is a very straightforward question. It's probably classified as an easy problem in exam, and we'll end over here for this particular question.